Okay, so we are continuing on part 2, and the description when you add to a function, that's going to shift. Let me write that down instead of just up. Go. There we go. We want to shift or translate up C units. Now C is just a letter. We use C for constant. So what that looks like is that the x coordinate stays the same, and what we do to the y coordinate that they give you is just add c to that. So the x coordinate does not change, but the y coordinate does. Same thing with this next one, except now it's shift down c units. So again, the x coordinate does not change. This might make a little bit more sense when we get to these problems. Right now you just might want to write this down. But then when we get to this one, it seems backwards, but the best way I can explain this is when it's inside the parentheses, you would set what's inside the parentheses equal to 0. So when you subtract c over, it's backwards. And you may remember that from Algebra 2, that it's shifting left c units. Depending on what c is, if c is like 3, you shift to the left 3 units. So this would be written in the form x minus c, and the y coordinate stays the same. Same thing with this one, it's backwards, and I would go through the same explanation. That is shift right c units. So it's x plus c, and then the y stays the same. So then moving on to the next one, you probably noticed when the negative was on the outside, that's a reflection over which axis? Well, when it's negative y, it actually reflects over the x-axis. So when that happens, the x stays the same and the y is negated. Again, you may remember this from Algebra 2. Same thing in the next one, except it's reflecting over the y-axis, so that means we negate the x-coordinate and the y stays the same. This next one is just a fancy way, let me write this down first, of saying that any value that was below the x-axis, the absolute value means it needs to be a positive value. So anything that was below the x-axis will move above the x-axis. Which is very important once we get to calculus. So keep this in the back of your mind. I know calculus is a year away, but we're going to get there. And this last one is a dilation. And some math teachers are more specific. They would say a vertical dilation or stretch or compression, depending on what A is, by a factor of A. Stretch of A units. A compression or a shrink of A units. So again, the x coordinate stays the same, and you multiply the y coordinate by A on that. So as we move forward in Algebra 2, you should have memorized or recognized that x squared is a parabola shape. So if you plug in 2 for x, you get 4. Negative 2 when you square it is positive 4 as well. So make sure you know these before you actually do these transformations. Absolute values of B shape, as I mentioned before. Anything that would have been below the x-axis gets flipped above the x-axis. That's why we write it like that. And we get our B shape. The next one's the cube root, which is basically a skinny square root function. Now the cube root of 1 is still 1, but then the cube root of 8, which I don't think this graph even goes to 8. 1, 2, 3, 4, 5, 6, 7. So like right here, the cube root of 8 is 2. But what's different about this is we can cube root negatives as well. And then cubing something, just like what I mentioned. 1 cubed is 1, but then 2 cubed is 8. So it is a very high number. But then when you cube a negative, you should know, and remember from Algebra 2, that you get negative values on that one. So make sure you memorize these. So as we describe our transformations on the next section, basically what it's saying is, okay, well, if we're adding inside the parentheses, that's your clue that you go left 2 units. Subtracting on the outside means we're shifting down 3, and the fact that it's a quadratic, it's being squared, that's your clue that you have a parabola with a vertex at -2, 1, 2, -3. And if you're really good at this, maybe you learned it last year that you go up by 1 and then you go up by 3 next. And then you keep going. And then looking at the next one, you can see the parent function is the absolute value. So that's your V shape. The negative on the outside is an x-axis reflection. The plus inside the absolute value is saying that we're shifting left 1, and the plus on the outside is saying up 4. So when you go to your graph, your vertex will be left 1, up 4, and instead of being an upwards V shape, it's a downwards V shape, like this, downwards on this side. And it just saves you time. You don't have to create a table to get all of these points. That's why we teach it this way. Now, let me change colors for the next one, because a lot of students get confused now when we have a negative right here. And I think it works if you actually show students like that, yes, it's a y-axis reflection, but then they say, oh, well, the plus told me to go left. Well, not quite correct. Because if you subtract 2 over, so you get negative x is equal to -2, and then divide by -1, you get x equals 2. This is actually shifting right 2 units. And that's the clue when you do a y-axis reflection, is this plus actually stays the same. And then that minus does not change. That -3 is saying we're going to shift down 3. So our cube root function will be right 2, down 3. And the y-axis reflection is saying instead of going up and to the right, it's got to go down and to the right. And then because it's a cube root, we also have these values. And feel free to use a graphing calculator to double check that I have the correct answer here if you are still confused. Double check my work. Same thing with this one. We have a y-axis reflection. Let me get a bolder color for this. And as you get better at this, so I've been doing this for years, I already know that this is going to be shifted right 4 and also up 1. But if you're still confused, think about, okay, well, if I put what's in the parentheses equal to 0, subtract 4 over, and then divide by -1, I get that right 4 notion that I mentioned. So right 4, up 1, and it's a cubic function. Maybe I should have wrote that down somewhere. Whoops. Cubic. So my graph looks, instead of going up and to the right with the y-axis reflection, we are going down and to the right. So it looks something like, cubic is really skinny, so that's a poorly drawn cubic. There we go. Just trying to throw in a little bit more for you is this table. So as we look at this table, basically what you are thinking about, well, as you look at these rules, it might make more sense if you actually write it out as rules. Notice that the x-coordinate is not changing at all. But if you think of f of x as being the y-coordinate, which it is, it makes perfect sense to just write -y plus 2. So the x-coordinate for g of x, so this is f of x, this is g of x, the x-coordinate does not change, so this -3 stays -3. The -1 stays -1. 1, 3. 3, and 5. But then you have to use this formula right here with your y-coordinate. So pretty much what it boils down to is negative of 5 and add 2 to it. So you get negative 3 for your y-coordinate. Negative, now I'm looking at 1 plus 2. So you get 1 for your y-coordinate. Well, don't forget the negative of negative 4 makes it plus 4. So you get 6 on this one. So this is actually going to be the same as that value. And negative 2 plus 2 will give me 0. So we can find our ordered pairs now by just putting it together. I believe on the next page they want you to graph. No. Okay, let's go ahead and look at the next one. I think I have enough time to get this done. So the key to this is remembering that with your x-coordinates, x plus 2, that's actually shifting left 2. So if you were to write the function this way, where xy becomes, because it's shifting left 2, you want to do minus 2. And then your y-coordinate, treat this as f of something is your y, so it's 3 times y minus 3. So as I look at my x-coordinate, is negative 3. Well, if I do negative 3 minus 2, I get negative 5. Negative 1 minus 2 is negative 3. 1 minus 2 is negative 1. 3 minus 2 is 1. 5 minus 2 is 3. But now the y-coordinate is going to be a little bit trickier. So my y-coordinate is 5. So plugging in right here, well, it's 3 times 5 minus 3. So 15 minus 3 is 12. 3 minus, well, I guess I should point out that I'm doing 3 times 1 now, minus 3 to get 0. 3 times negative 4 minus 3. So I get negative 12 minus 3 is negative 15. Again, this is the same value as this one up here, so don't do too much work. 3 times 2 is 6, minus 3 is 3. And now we have enough information to say our ordered pairs, negative 5, 12, negative 3, 0, negative 1, negative 15, 1, 0, and 3, 3. I'm going to pause here and finish up the next video here shortly.